Today we want to talk about graphing inequalities in two variables. And we'll work with part A right here. And we have y is greater than 3x minus 1. So we're going to essentially graph them like they are linear equations. So the first thing we want to determine for part A here is what the slope is. So I take a look at the equation. I notice that the slope is 3. I need the y-intercept. Again, looking at the equation, I see that the y-intercept is -1. So we're going to use that in the slope-intercept method to graph the inequality. So I can start at the y-intercept of -1 and plot a point there. And then to get the subsequent points, use the slope of 3. So if the slope is 3, I want to go 3 units up and 1 unit across to get each subsequent point. Okay, before I connect the lines, I want to determine whether I should do a solid line or a dashed line. So what we have to remember when we're doing this is that anything that does not include an equal sign, for example, greater than and less than, will get a dashed line. Anything that does include the equal sign, like less than or equal to or greater than or equal to, will get a solid line. So I look at the inequality here, and it's a greater than symbol, so I'm going to use a dashed line here. Okay, so we've got the line in, and now we just have to determine where the solution area is. You can see that the line is basically a boundary line that separates the coordinate plane into two half planes, and we want to determine which half plane contains the solution. So one way to do that is to use a test point, and what we could do is use the test point 0, 0, since the line is not going through 0, 0. So I have my original inequality, y is greater than 3x minus 1, and I put zeros in for x and y. So I come up with 0 is greater than -1. So we have to determine, is that true or false? Since that's true, we're going to shade the area that contains the test point. So the shading would look like this. And now the graph is complete. Another way to do this, if you're not sure about using a test point, is to use the calculator. And we can enter the inequality into the calculator and determine from there where the solution area is, and then transfer that to our paper. So we have y is greater than 3x minus 1. All right, so we see that it gives us the solution region on the left of the boundary line, which is what we had on our paper, so we know that we're correct. Okay, we could try another one here. We'll do A again here. And again, I want to find out what my slope is. So I look at the equation, or at the inequality rather, and I see that -2 is the slope. I look for the y-intercept, and I see the y-intercept is 1. While we're at it, we can take a look at the inequality symbol here. It's greater than or equal to, and then we can give ourselves a heads up that we need to put in a solid line after we plot the points. So again, we'll start at the y-intercept, which is 1, and then we'll use the slope to get the subsequent point. So if it's a -2 slope, we're going to go down 2 units and 1 unit across. Okay. So since we're using a solid line, we'll get that in now. And then lastly, we need to find the solution region. So again, since the 0.00 is free, the line is not going through it, we can set x and y equal to 0. So here's our original inequality. Okay, so here it's telling us that 0 is greater than or equal to 1, which is not true. And when it's not true, we want to shade away from the test point on the other side of the line. So our shading would go here. Our solution region is to the right of the line. And then we could go to the calculator and check that just to make sure we're good. So this one is y is greater than or equal to. So y is greater than or equal to -2x plus 1. Okay, and sure enough, it shows that the shading is to the right of the line, and that is what we had on our paper, so we're in good shape there. Here they want us to write an inequality for the graphs here. So what we want to do is to find the slope and the y-intercept to start with. So let's see, the y-intercept here is going to be -2. And if we count the boxes from the slope, we're going down 1 and over 1 for the subsequent point. So our slope is -1. So I'm going to have y and -1x, slope is -2. Okay, we just have to figure out where the shading is here and what that means in terms of the inequality symbol. So what you can do is, again, use the calculator to help you figure that out if you have doubts about calculations. So we'll try y is less than -x minus 2. It shows us that the shading is on the bottom. So the symbol is less than. Part B, we'll do the same thing. We'll take a look at where the y-intercept is. So notice they're going by 2's here. So looks like the y-intercept is 3. And then we have a point at 4 and -4. So if we count the boxes, we're going down 2, 4, 6, and 1 is 7 over 2, 4. So negative 7/4 is the slope. Negative 7/4 is the slope, and 3 is the y-intercept. We just have to figure out what the symbol is. So again, we can do the same thing with the calculator. So we could try y is less than, and it was negative 7/4. X plus 3. Okay, let's compare that to what they have. They have shading on the same side, so less than would be our symbol. Okay, so here we have a inequality in two variables, but it's absolute value. So let's take a look at how we need to do this one. So they give us 1 minus y is less than the absolute value of x plus 2. We need to get y isolated here. So the first step, let's just write this here. So the first step is I've got to get this 1 over to the other side, so I'll subtract 1 on both sides. The next step would be to get y to be positive, so I would have to multiply the entire equation by negative 1. So that's going to give me a positive y. And remember, when you multiply or divide by negative 1 to isolate y, you need to switch the symbol, so that's going to become greater than, and it'll be a negative absolute value of x plus 2 plus 1. Okay, so the next thing we want to do here is figure out where the vertex is. So we know that the vertex is h and k, so that means negative 2 and 1 are the vertex. So let's plot that, negative 2 and 1. Okay, we know that the slope is negative 1. Okay, we'll look for a here. It's negative, so negative 1 is the slope. So I'm going to go down 1 and to the right 1 each time. And because there's symmetry, I can do the same thing on the other branch. Now I have to determine whether I'm using a solid or a dashed line. Since the symbol is greater than, we're going to use a dashed line. And then the last thing we have to determine is whether is where the solution area is going to be. Since we are greater than, then our solution will be above the line. So we'll shade here. And we have it graphed. All right, same thing here. We have y minus 4 is greater than or equal to 2, absolute value of x minus 1. Okay, so next thing we want to do here is to make sure we get rid of this 4. So now we have y is greater than or equal to 2 times the absolute value of x minus 1 plus 4. Okay, so again, we want to determine where the vertex is. So we notice that the vertex is at 1, 4. So I want to plot that point to begin with. And we notice here now that this time the slope is 2. So that means we're going to go up 2 and to the right 1. Okay, since we're greater than or equal to, we're going to use a solid line. And lastly, we need to determine the shading. So since the symbol is greater than or equal to, it's going to be above the line. So we're going to have our shading right inside. Again, here they give us the graph and they want the inequality. So what we want to figure out first of all is where the vertex is. Let me take a look at the vertex here on the graph, and we're at 3, negative 2. Okay, so we know it's going to be y equals, or not equals, rather we have to figure out the inequality symbol, but it's going to be y, and then on the other side it's going to be the absolute value of x minus 3 and then minus 2. We need to figure out what symbol is going to go there. So we notice that the shading is above the line and that the boundary lines are dashed. So it's going to be y is greater than the absolute value of x minus 3 minus 2. Okay, same thing here. We want to determine where the vertex is. So negative 4 and 3. Okay, the slope here is, let's see, going down. Going down 3 units and to the right 3 units, so it's a negative 1 slope. All right, so we're ready to write it. So it's going to be y. Now the lines are dashed, so it's got to be less than or greater than. The shading is above the line, so it's got to be greater than. So our symbol will be greater than. And the slope is negative, so we're going to have a negative sign outside the absolute value symbols. So we have, since it's a negative 4, 3 vertex, it's going to be x plus 4, right, which would be the same as x minus negative 4 plus 3. So here's our inequality for that graph.